Hello, I'm going to go through homework 2. So, so in homework 2, you get 3 questions. The first 2 questions are just analysis. You can just read and interpret the results. So I'm not going to go over them, but I will go through question 3. This is a coding question. So it is not that difficult when you understand what's going on, but it could be quite hard if you do not have basic idea about R. So there are some special commands you need to use to implement this question. Okay, so before starting, let's think about the data first. Our research question is about the effect of smoking on birth weight, baby's birth weight affected by mom's smoking status, right? So usually birth weight is a very important health measure, and so if the birth weight is too low, then the infant's health is very dangerous. Like could be quite dangerous if the birth weight is too low. And interestingly, in economics, there are many researches showing the correlation between birth weight and future salary. So if you are heavier when you are born, then your expected income is higher than those who are born with lower birth weight. So there are many explanations why that happened, but anyhow, we are going to study the birth weight and particularly the effect of mother's smoking on birth weight. So I'm going to upload this data file. So our data is on Excel, and particularly we are interested in birth weight, right? In maybe grams, right? So on average, an infant is about 3 to 4 kilograms, which is 3,000 or 4,000 grams. So they are measured like this. Also, the other variable we are going to use is the smoker, right? 1 means smoking, mother is smoking, and 0 means no. So smoker, non-smoker. And we have exactly 3,000 observations. We observe 3,000 babies, infants, on their birth weight and their mother's smoking habit. Okay. Okay. Today, based on your homework 1 submission, what I found is, it's you don't have good idea what is a code. I like most of you did well. You know how to implement what I asked for in homework 1. But the problem is when I ask you to submit your code, some students had no idea what is a code. What is that? So I understand that is natural for a first-time programmer. So today, what I'm going to do is I will do a little different from what I did last time. So as you see, I don't have R open right now. I don't have R now, so I will close it. Instead of doing R, I'm going to use Notepad, right? I'm going to write my code directly on here. This is the Notepad, the basic program on Windows. I don't know what's on Mac, but I believe there must be something similar. Like basically, it's a text editor. You may use Word, or you may open just an empty email, and just whatever you can type would be fine. Okay. So my plan is I'm going to write all my codes on this text editor. All right, I'm going to write down all the codes here, and then when I finish, I'm going to copy them and then transfer them to R. So that is my plan. That is how a typical programmer works, right? We do not work. Programmers do not work directly on the program. Like they can, but usually just a text editor is enough if you're a good enough programmer. Of course, you need to use Google to get some help. So Google and text editor would be enough. Okay, So now I'll be your Google. So let's just open it, and I'm going to close my video. You don't need to see my face anymore. Okay. So, and to think about what you're going to do, I made an outline. So you have to have a good idea what you are going to write in your code, right? And take step by step. By the way, there is no part 6. I found confidence interval could be too hard. So anyhow, you are going to load your data first. That is the first line of first a few lines must be about loading data. And then in part A of the question, I ask you to calculate the overall average of the birth weight, and then calculate the average birth weight for those whose mothers are smokers, and then calculate the average birth weight for the babies whose mothers do not smoke, right? So we are going to calculate 3 averages. That is step 2. And in step 3, we are going to run a regression of birth weight on smoker variable. I mean, by smoker, I mean the name of the variable. And step 4, now we are going to calculate the standard deviation. Standard deviation in 3 ways. First, I will calculate the overall standard deviation, and then, like before, we are going to calculate the standard deviation of birth weight for smoking mothers, and then standard deviation for non-smoking mothers. So overall, smokers, non-smokers. So there are 3 different standard deviations we are going to calculate in step 4. And then in 5, we are going, in step 4, by calculating the standard deviations across groups, what we want is to check the heteroscedasticity, right? So if the standard deviation of smokers is different from that of non-smokers, that implies heteroscedasticity. The standard deviation is affected by the regressor, smoker. So in that case, we will need to update the standard error accordingly, because the default standard error in regression is calculated based on homoscedasticity assumption. Homoscedasticity, which means the standard deviation is the same across groups. So you can see, like from step 4, you will see it's not the case. So we will need to update our standard error using robust formula, right? And step 6, there used to be another question, but I erased it. It's kind of complicated, so you don't need to mind. Okay, let's start from the first step, data loading. On Brightspace, I will upload the data file, Excel file, under this name, birth weight _ smoking.xlsx. So then, imagine on R, what you need to do is, first, you need to set the directory, the folder, so working directory, to the folder where the file is downloaded, or where you save the data file, right? So I'm going to set the working directory, and then we did that in homework 1. We need to install a package, readxl. Readxl package enables us to recognize Excel file and transfer the Excel file into R. So, and remember, package is a kind of app on your smartphone. So you have to install a package to use a certain functions, commands, right? So we are going to install and load this package. And then after installing and call for the package, we are going to load the data file. And the name of the command is read_xl. And then here, you need to think about your data name. So when you load the data, you have to set its name, because you're going to use the name again later to call for the data set. And I'm going to use this name, homework 2 data, HW2 data. So, okay, this is what you have in mind, what you should have in mind when you implement the first tab, data loading, right? Data loading consists of these tabs. So now let's do that on text editor, right? So your code, in your code, I'm going to say there are two different types of content. First, you can just write down some like phrases or some sentences to yourself or to whoever going to read it, who's going to read your code. So for example, I'm going to start my code with, so this is an example code for homework 2 in like ECO420W in spring 24. So it's kind of just for my own record, right? But remember, this is just for my own record, so this is a sentence. I'm talking to myself, but I'm not talking to the program. It is not a programming word, programming sentence. So then you have to put pound in front of that. So by starting a line with pound, computer does not recognize this. Computer understands that this is not a code. This is not a command to the computer. It is just for my own record, right? So you may like put it like that. Today, date is March 6, 24, something like that. So these kind of sentences will help you like to keep track of your code. Like for example, usually last updated date is like this. Okay. So also this will help you to understand your code, structure your code. For example, I will include this in my code. I will write down, oh, by the way, I'm going to zoom. So now it should be better, right? So I write down the title of the step so that I can understand what I do here. Like even if I save it later and like I save it now and like do it tomorrow, then I may forget what I have been doing. So that then this line will help. Also, this is a small tip. You may just use multiple pounds just to make it special, right? So then, like this, I will explain what I'm going to do. Set the working directory. And the command is set working directory, and you have to choose your own directory. Oh, excuse me, I am checking. Oh, what happened? Some error happened. I don't know. I want you to copy it, so something happened. Anyhow, so this is my working directory. Okay, so of course you have to choose your own directory, right? This is my directory, and I just set the working directory, and then install package. I'm going to install packages read Excel. We did it last time. By the way, it's tricky. This kind of error like will happen. So, or like first when you do it, like so for example, at first, oh, it's slow. Yeah, I first wrote it like this. Then there are two problems. First, there is a typo, right? You have to do it like this. And you have to put quotation marks in here. That is the syntax. So for the computer to understand what you are saying, you have to follow the syntax, but like, it is not easy to do so. It's not easy to memorize everything. Or like last time when I first tried myself before recording this, I forgot to put S here. It should be installed packages, right? But that isn't a problem. As long as you save your code, as long as you keep your text file, and if you find an error, then it is easy to edit, right? So I recommend you this way. Anyhow, that is not a big problem. Like even if like there will be errors, and editing should be easy enough. Like after recognizing there is an error, and also that is how you learn programming. Okay. By the way, so you have to install this package if you haven't. But you know that in homework 1, you have already installed this package. If so, you don't need to include this line. And then instead of deleting that, you can just put another pound here, right? By including this pound, it is like deleting this line because the program will not recognize this sentence, this line at all. Does not do this line. So this is an easier way to delete one line, because later if you use another computer, you may need to revive this sentence, this line, then you can just delete this. And then if you need to delete it, like again, like that, revive it by deleting pound. The pound is very useful in many ways. Okay, and then after installing this package, you have to load it. Right? Load package is library. From the library, you load this package. Another typo. It's not a problem. This typo does not matter because the program, the computer, does not take this as an input. So because it started with pound. So, but anyhow, I fixed it. And another tricky thing is that there is no quotation marks here. You have to have quotation marks here and there, but that is not a big. That is really minor. And when you see an error message, then still you can fix that. So that is not a problem. And then I'm going to load the data file to data frame named HW2 data, right? So this is explanation to myself, annotation to myself, and I'm going to copy what I just had. This is what you are going to use, right? So left hand side is the name you set, and the right hand, this is the code, this is the command, and here this arrow is assign. You are going to assign into this name by this command, right? And this command loads the data under this path. Okay, of course this path will be different, and because we set the working directory, actually you may delete this much, but anyhow, so to be more careful, like I put all the path. Okay, so this is the end of step 1, right? And I'm not going to implement these lines until I finish all the code, right? So this is how programmers program. Now let's go back to PowerPoint. Here, we are ready to work on the data. Data is ready, should be ready. And then we are going to calculate the average, right? Remember, our second step was to calculate the average overall and then by groups. Before doing that, remember on this data, the name of the data set is HW2 data, and under the data set there are many variables, as you saw from Excel. And particularly we are interested in birth weight and smoker variables under this data set. And in R, we are going to denote them as HW2 data dollar mark birth weight. So birth weight variable of this data set and smoker variable of this data set, right? So when you need to specify the data set, this is the syntax. Dollar mark will specify the variable from a certain data set, okay? And then, for example, calculating the average is pretty simple. Just use mean command, mean of the variable, right? So I will write that in our text, right? So now step 2, calculate the averages, right? Like this. And then overall average. Overall average will be mean HW2 data birth weight. Okay, so we calculate the mean of this variable, and the variable path is under data set named HW2 data. Okay, and then next we need to calculate the average by smoker group. Okay, that is what we have to do next. And this is not straightforward. The command you have to use is aggregate. You are going to use aggregate command, and it has 3 arguments. First, we are going to aggregate the birth weight variable by smoker variable. So the main variable, comma, least another variable, group variable, and then comma, and function, we are going to apply mean function. We are going to apply this function by this group on this variable. Okay? So the syntax is more complicated. Now remember, aggregate. We are going to use aggregate command, and our main variable is HW2 data birth weight variable. And when you aggregate, you have to have like groups, list, which is based on which should come into option list, and then you define group like this. You are making list of groups using smoker variable. Okay, and then finally our function is mean, right? We are going to apply function mean for each value of this variable, basically on this variable. Okay, then automatically it will calculate the mean of this variable by this variable, by smoker. Okay. So of course, so now I'm teaching you what we have to do here, like to calculate the average by another typo. Average by smoker, you have to use aggregate command. But if you have no idea, if you have to do it by yourself, of course you have to Google that. On Google, say how to calculate average by group in R. Then you will see a lot of helps. And then that's how I learned this command. Okay, so in the end, you have to learn how to do it by yourself. Google will do that for you. Okay, let's see. Next, step 3 is regression, which is pretty straightforward. We did it last time. We know that we are going. To use. We are going to use LM command, which stands for linear model, right? And you can just directly start command with LM, but I recommend you to save your results, your regression results, to something. I'm going to name the results as REG1, regression 1, right? But it can be any name. You can change your name, like change the name of the regression output. So in the end, our command will look like that. Regression, like this is the name of the regression output. You may change the name. reg1. I chose reg1 and arrow. So we assign this much into reg1, right? And then lm command. So here you have to specify the dependent variable on the left, wiggle, and then on the right side of the wiggle, you have to include regressors. So in our case, we simply include birth weight on smoker, and then you specify data separately. So because you are going to specify data like this, you don't need to put dollar mark in the variables, right? Because the data is obvious. I already set the data like this. So this will be your command, and then it is only saving the output into this, so it does not show you the estimate results. To see the results, you need this command. Okay, but you can use this command whenever you want, because already it is saved in your memory. The output is in your memory, so you don't need to do it right after the regression. Anyhow, let's see. So step 3, regression of birth weight on smoker variable. Okay, and it is easy. We are going to use reg1 as the name of the output, for the name of the output, and lm birth weight smoker. Relationship is birth weight on smoker, and then data is hw2 data. The name of the data is hw2 data. Somehow my computer is super slow, maybe because I'm running PowerPoint and a recording program at the same time. Anyhow, so this is implementing the regression, and if you want to see the result, you can type summary. Then it will return the typical regression table about your coefficients and your standard errors. Okay, that was step 3, which was easy because we did it last time in homework 1. And in step 4, we are going to calculate the standard deviation. Again, 3 types of standard deviations. One is the overall standard deviation, and the others are by smoking groups, right? Depending on the smokers, smoking mothers, like whether smoking mothers or non-smoking mothers. Okay. The overall standard deviation code is overall standard deviation is simple, like by typing SD. SD is standard deviation. So now you have to just include the variable, right? Simple. That will calculate standard deviation of birth weight variable under the data hw2 data, right? And then standard deviation by group. We are going to use the same command as before, aggregate command. Basically, we are using the same structure. I copied it, and I will change this part only to SD. That is how we calculate standard deviation by groups. Okay, so aggregate, idea is the same. We are going to aggregate this variable by each value of this using function standard deviation, right? So we'll apply standard deviation on this variable by this group. Okay, that is standard deviation, right? Only this part changes from the average part. Okay, so now you understand how we use aggregate variable. Clear? Last, regression with robust standard error. So remember, we learned homoscedasticity and heteroscedasticity depending on how the variance of the error term changes according to the value of regressors. The problem is that default is homoscedasticity because the formula is much simpler. However, it is unlikely, right? In most cases, the variance is usually affected by the regressor. So we hope to generalize our standard error to incorporate to accommodate heteroscedasticity. The problem is, so in economics, it is really common, right? It is really common option in economics, but I realized that in statistics, heteroscedasticity is not as seriously considered as in economics or econometrics. So I found it really hard to implement this in R. In Stata, which is more economics friendly, it is pretty straightforward. There is a simple option. But in R, we have to use a separate command. And that is why I deleted the sixth step, right? The last confidence interval using heteroscedasticity is not easy. So I dropped one question. Anyhow, then we are like our plan is we are going to use COEF-TEST. We are going to use coefficient test command to implement robust standard error, right? So here I'm going to call it like it is robust standard error, but also called heteroscedasticity consistent variance or heteroscedasticity consistent variance covariance estimator, something like that. So in R, we are going to use coefficient test based on REG1. This is where we saved our regression output, right? So based on the same output, we are going to recalculate the test for each coefficient using variance covariance option heteroscedasticity consistent, right? Okay, just copy that. Step 5. Heteroscedasticity consistent standard error is what we want in this step. And because we already saved our regression output here, so we may recycle this output again. We don't need to run the regression again for here, right? So we can just recycle this, and we will use coefficient test based on regression 1, and we have to include an option about variance covariance matrix, which is like this. So you may, if you have put no option, if you do not include any option, you are going to see exactly same standard errors, t statistics, p-values. But we would like to recalculate those things using heteroscedasticity consistent option. So we will include like this. This is it. This is step 5. So you can save this as a file somewhere, and you may just submit this file after you check if it works. Check it works, and then you can submit this text file. That is also a good like legitimate code. Now I'm going to open RStudio, or like open RStudio. So this is my RStudio, and instead of typing your command here, do not type commands here, but click here, and then you will see R script. This is where you put the commands, your code, right? So copy. Somehow my keyboard does not work. Copy and paste, right? So I copied and pasted all the things, and as you see, the line with pound is green, which means it is not recognized, right? But the line without pound sign, start with like is black. So it recognizes what is a command and what is not a command. This is not a command. And like, so it recognizes or what it has to work on. Anyhow, so then here, select all, Control A, and run here. Or you may just run one line. Like if you do it like this, it will run only one line. But now I want to run all the code at the same time. And then fortunately, I didn't get any error message until here. So let's have a look. So this is when I run all the code that I wrote on the text editor. So this line is just talking to myself and also annotation. And there is no result for this. The set working directory and library, call for a library package and import Excel file to here. And then and when you put mean command, it returns output like this. So this is the average birth weight overall, right? So the overall birth weight is 3 kilograms, 3.3 kilograms, 3.382 kilograms, right, on average. And then here we calculate group average, right? So 0 means, first column means smoking variable is 0, which means it is non-smoking mothers. From non-smoking mothers, the average birth weight is about 3.4 kilograms. But from smoking mothers, the average is 3.17, right? So you see the different averages across groups. And then here, regression, we run a regression, and then we summarize, or this command is to show the results like this. So this is the main table. Okay, so intercept is about 3.432, right? And the slope of smoker variable is minus 253. So, right? This means when this variable changes from 0 to 1, the effect on birth weight is about minus 253 grams. And we have standard errors here, and t-statistics and p-values. Okay, this is the standard regression results. And also, you have like degrees of freedom here. Standard error of the residual, standard error of the regression is like 583, multiple R squared, and adjusted R squared, and F statistic, degree of freedom, p-value. All the regression results are collected here. Okay, and what is interesting here is, look at this intercept estimate, 3432.06. This is this. Okay, remember when I explained the dummy variable, so smoking is a dummy variable, right? If smoker is 1, then so the mother is smoking, and if 0, mother is not smoking. So the intercept is the average of the reference group, which means when smoker is 0, right? And minus 253 is the difference between these two groups. If you calculate the difference, then you are going to get the same number like this. So that's exactly what the regression is doing in this case. Okay, so keep going. Standard deviation, when you calculate standard deviation, it is 592 grams, but by group, it's different. What is interesting here is, by group, the standard deviations are smaller, right? This is possible. Right. So, non-smoking mothers have 584 grams standard deviation, but smoking mothers have smaller standard deviation, 580. So, they are different a little bit. So in this case, actually, it's pretty homoscedastic, right? Yeah. So heteroscedasticity is not a big concern here, but just as an example, we tried it. Okay, and then step 5, up to here, fortunately, I did not have any typo. Everything was nice. If you had a typo, you are going to see something like this. Error in something. Warning message or error message. Then you can go back. You can go back to your code and like fix your error. That is always possible. Okay. So, but I intentionally left this part wrong. There is an error in step 5. It says it could not find function COEF test, right? So that means this is because the command is not recognized. The program does not understand what this means. That's because you do not have a certain package. You have to have a package for this command to be available, right? And then back to our editor, or you can just directly edit on R. I know that. I know the answer. Like, for example, okay, let me do it here. So here, like you have to Google it. What package do we need for coefficient test command in R? Then I learned LM test, linear model test. You need this package, and then you have to call for you have to use the load the package using library command. Now then, you don't need to run all the lines, but you just need the last 3 lines, right? We have done all the previous lines. So let's choose these 3 lines, drag 3 lines, and run it. And let's see. It will install things and blah 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 blah. Still, so it's about like version. Our version is not updated. Not a problem. So try to read it. Not a direct error message, just saying it's installing and like, version problems maybe like here. But there is another error, right? So now the problem is the program understands coefficient test command. This part is okay. But this does not understand this option, right? Okay, something is missing again, right? Then now go to Google and search for like what package do I need to use VCOVHC for coefficient test command in R. Then I learned another package like this. So you may wonder what sandwich package means. So in heteroscedasticity formula, the final formula is the form of like A times B times A. So always it's like A times B times C times B times A, something like that. So something is like it's symmetric, right? So it looks like sandwich. The start and the end, the beginning and the end are always the same. So like it starts with something, then it should end with the same thing. Like so, and in between them there are different like formulas. So it's like sandwich start and begin with bread and end with a bread. Like formula is like we call that sandwich formula. So now it should work. Try this. Okay, now you get new result. Compare like now standard errors are 11 and 26. Compare 11, 20. Okay, so this is the original regression result. The coefficient of smoker was 26.95. Like here, let's come back here. It's now 26.841. So the standard error is recalculated based on heteroscedasticity. So slightly change it, but actually the change is not that big because we learned standard deviations are not much affected by X. Okay, but there is a slight change because there was a slight change in the standard deviation across group. Okay, thank you for watching. I hope it helps you. So after doing this, you have to save this, right? Save it, and save it like whatever you want. I'm going to save it like this and send that file to me. Attach the file to email, and you have to learn that, like, or watch some YouTube videos or whatever. If you do not know how to find the file, attach the file to email is more important than learning how to program. Okay, good luck. I'm going to post homework 3 pretty soon. Bye.